Weatherbell Analytics meteorologist Joe Bastardi here. Saturday summary. A lot of shock and awe on social media about it snowing in the Midwest today. I don't know why that was a surprise. It's been a well-telegraphed storm. It's not going to get all the way to the East Coast, but it will get to the Appalachians tonight from West Virginia up into Pennsylvania before falling apart. Now, what's been going on all winter is Madden Julian oscillation. If you took the mean of the MJO, it would be centered someplace in here. See, we had the big rotation out in here. It has avoided these cold phases like the plague over the last 3 months. So it's been in the warm phases or neutral phases, and it has just led to a majorly warm summer. A warm summer. Freudian slip, it felt like summer. A major league warm winter across the United States, perhaps the warmest on record, as you can see. Certainly population weighted, it's as warm as you've ever seen it. And a terrible bust on my part. And the reason there is that bust is because of what happened with the Madden-Julian oscillation. I was anticipating a different look in the sea surface temperatures. What I did was I bought the European and US models on the sea surface temperatures, which showed what we call a warm PDO, and that's not what happened. All right, the center of the center of the warm water in the Northeast Pacific was further west. In the tropical Pacific, it was near and west of the date line, not near and east of the date line, which is important because what happens is when you get that warm water in that one spot around the date line to the west of the date line, sets off a lot of thunderstorms there. That forces the phase 6 of the Madden-Julian oscillation in the means. And we just could not get out of that. So even though there was some favorable Indian Ocean indicators, they were overwhelmed by what was going on in the Pacific. And that's the problem. Next week when I do the hurricane forecast for you, we're making a forecast based on the forecast for the pattern for the summer and hurricane season. And that's a fascinating situation in and of itself. So that should give you a hint that there's something interesting coming at you. But you have 2013 sticking out with a similar Pacific look, and yet we had a very low ACE index and almost a non-season in 2013. So sometimes these things go awry like this. And I will tell you this, I don't, going forward, you guys know how I'm a big history buff. I don't think we can use a lot of the things that we were using before because with the sea surface temperatures as warm as they are, what happens is you may get the relationships that produce a certain value. Okay, let's say you have a value. Let's just take the Hawaiian Californian oscillation. Okay, let's just make one up. Okay, let's say that is based on the sea surface temperature in Hawaii versus sea surface temperature at Marina del Rey, California. Okay, so Honolulu versus Marina del Rey. And let's say if it's a -4, if there's a 4 degrees Celsius difference in the standard deviation, it gives you a certain Hawaiian California oscillation value, right? Well, what happens if that 4-degree difference 30 years ago may have been 2 degrees or so colder than the 4-degree difference now? In other words, what happens is, yeah, okay, you've got the 4 degrees difference, but it's with a water temperature that's 2 degrees warmer. Well, you're not going to get the same feedback as that. So what I'm exploring is, somehow trying to normalize the weather pattern that we're in now versus where we were 30, 40, 50 years ago, because the feedback mechanisms are going to be different. So I think it's almost impossible to have widespread cold winter like we did in the 70s now, for instance. I mean, what we did this year is we had it cold up in here, or colder than normal in here, and we had it normal in here like this. And this is all colder than normal, okay? So I'm not trying to, sugarcoat this any, but we didn't go like -6 or -7. We went a couple of degrees below normal because, say you can't get as cold as you used to get right now, all right? And this is not me saying, oh, it's because of CO2. It's not. It's because of water vapor. I could just show you the relationship. The oceans are warming, and people say, well, the oceans are warming because of there's more CO2 in the air. That in turn, it's absorbed in the 4 micron band between 13 and 17 microns. And what happens is that's heating things up around it, preventing the sea surface temperatures from falling. And that's not the case. Well, let's put it this way. Maybe that's the case, but if you actually go and look at what's going on over the tropics, you see what's going on. It's drying out. It's not getting more moist in the upper levels over the tropics. And see, that's the key, because increase in water vapor where it's very cold leads to an increase in temperatures. Now, if you are drying out over the tropics, what does that imply about cloud cover over much of the tropical Pacific into the we're talking between 10 north and 10 south. What does that imply if it's drying out there? More sunshine. What happens when there's more sunshine beating down on any surface? Well, guess what? The surface warms, right? And then that in turn gets fed back into the overall circulation. But for whatever reason, I don't care if it's because of the man on the moon spreading pixie dust around, all right? For whatever reason, the valuable lessons from this winter that were learned, and learned big time, believe me. And so, we get next winter going on, and we'll see what happens. But what we did say was, we've been expecting this return to cold. And people are in shock and awe that it's snowing, I mean, even in Tokyo, it's snowing right now, or it was snowing in Tokyo. And I'm like, yeah, take a look at what the pattern looks like over there, right? So this is because a lot of times, if you start cold, you'll end cold. And the problem is the bookends are really spread out this year. They were November cold, and then instead of coming back in later January, February, and March, into March, they waited till mid and late March to come back. And there may be a 2 to 3 week period where there's not much spring. All right, so we're not done yet. Now, what's happened is that 500 millibar, because of that warm water over here and all the thunderstorms going up, the release of heat fed this ridge, right? And this ridge forms near and just east of the date line. The jet tightens, feeds back, and you get lower than average heights in a brutal winter across in Alaska. And this warm water off the east coast is doing its dirty work too, deepening the Icelandic Greenland low, which in turn, you got to remember something, folks. The United States is closer to the equator than it is to the North Pole. So you need amplification into the nation to produce the kind of ration of cold air that you need to prevent your lack of snow frustration. I had to go a long way to get that. But with all this warm water the way it is, it tends to tighten the jet. So if you get these seasons where you got intense convection going off in this part of the Pacific Ocean, it feeds this, that feeds that. That in turn tries to lead to some kind of trough in the west, pumps the ridge in the east. Now, if the water's warm, it pumps the ridge even more in the east, tightens this jet, deepens this, which puts the ridge over Europe, right? So that's what we had happen this year. And that happened 2001, 2002, and 11, 12. There were similarities to that. Now, what's going on in the stratosphere is, there's a sudden stratospheric warming event coming. I'm not so sure we can use it. This is what we've seen all year long, all winter long. The stratosphere has been cold over the pole up there, 10 millibars. It's forecast to reverse completely. Now, if I saw this in January, I'd be going, oh man, well, that's what happened last year. We had a 3-week jump on that Arctic outbreak into the United States last year because of that, what was going on. Actually, a 6-week jump because what went on in the MJO in December that turned everything warm, then in turn fed back. There's some great articles on the MJO and what it does with stratospheric warming, and that may become more and more important down the road. But in any case, I don't know if I can use this because there is almost always a sudden stratospheric warming event in spring. I'll tell you, my physics of the upper atmosphere teacher, and those who subscribe on Weatherbell Premium have heard me talk about this. He upped my grade 1 point, not 1 letter grade, 1 point. What did I get? A B minus. I got a B minus in physics of the upper atmosphere. And it may have been a C plus, but because I brought him a strat warm alert, I had it spring term 76. I'll never forget it. I brought him the strat warm alert, and he was one of the kindest people I've ever met. Dr. Panofsky of Penn State. Well, Mr. Bastardi, you get 1 point added onto your grade at the end because you were vigilant. That's what he called me vigilant. And I said, oh, thank you, Dr. Panofsky. The funny thing about Dr. Panofsky is my dad had his textbook in college at Texas A&M. So it's like, hey, Dad, Dr. Panofsky raised my grade a point. My dad was, oh, you know Dr. Hans Panofsky? He was a dumb Panofsky. He had a brother. I can't remember his name, but they went to Princeton, and I guess Hans got a B in a course, and the other brother just got nothing but A's. So they called Hans Panofsky the dumb Panofsky. Unbelievable. Now, Penn State, when I was there, the professors were unbelievable how great they were. They loved to argue. It was like most of them, well, a lot of the times the real smart ones, they sort of had an ego. They looked down on the forecasters. You know, back in those days, folks, it was dynamist, synoptician, and then the climate people were at the bottom of the list, right? The climate people, you can't forecast the weather, so you go look at climate. That's what, and okay, you can't do the math, so you go forecast. So you did have a hierarchy of real smart professors that I was never that comfortable with, but we had a lot of great professors that they do the math, but they love to fight. They love to get into arguments over the weather with the kids, and it was really. I learned so much from some of those guys, including someone I went to work for later. I had his class, Dr. Joel Myers, his forecasting class, and you learn so much from them because they would argue with you. It wasn't like they got all mad. They got mad, but they got mad because they were in a fight. They weren't like mad 2 days later. They didn't care if they were in a fight. It was, let's see what the weather does, right? So you learn a lot that way. You learn a lot by competing and getting into situations where you're challenging each other. All right. This is 12 minutes long. I'm not even a quarter way done. All right, so back in November, the Mad-Julian Oscillation went into the cold phases, right? Went into the cold phases, and the result was the ridge went up over Alaska in November. And look at this in Europe, right? And this is interesting because a guy I learned a lot from, I'm not going to mention his name in case he doesn't want me mentioning his name, but he used to always say that a lot of times what you see in November will flip around and go back the other way. He says you got to look for a flip. If a flip occurs around Thanksgiving or around the winter solstice, you're in trouble, right? So in any case, we saw that happen this year. But that ridge went up over Alaska, and a lot of cold air came into the United States. And you can see the modeling for the next 30 days, at least on the climate forecast system, has much more ridge in Alaska. And it's got that trough there, so it's trying to transport colder air into the United States. And, of course, in November, we had a very cold November across much of the country. All right? It looked like, oh, boy, here we go. I don't think you can run the table coast to coast anymore. I mean, you go back and look at some of those winters in the 70s. It would get cold in November, and you wouldn't come out of it till April, right? But I don't think you can do that anymore. All right. All right, so let's take a look at European. Here's, see, 84 hours. So this is, I guess, Wednesday morning. There's a strong trough going by to the north, and that's going to, we have this one system going off now. There's another one coming through, and then we watch for this. But there's the ridge up over Alaska, so all sorts of Arctic air is getting into the pattern. And then we get to Saturday morning, and this is going to drive a very cold high-pressure system into the weather pattern in the central part of the United States. What we don't see is the blocking necessary to hold these things. It just goes out, right? So this is day 9, and day 12. Now this is getting kind of interesting because what could happen here is these things could hook over the top down the road in the long range and just lock that vortex in here. And the European has been correcting eastward with this feature, all right? A couple of days ago, it was way out here with it. So this trough may wind up really producing a major league cold air mass between March 20th and 30th into the United States. There you see where we are, day 15 there. Now, the Mad-Julian Oscillation, here's the problem. When we're in phases 1, 2, and 3, it's strongly correlated to cold, right? So what you're going to see is the computer models may be saying one thing, but they will probably correct toward these colder correlations, because these are strong correlations at this time of the year. So here's the European, and let me see, did I have it a couple of days ago? Yeah, look what it looked like just 2 days ago for the same time period. So it's correcting, and we may find that it just corrects so that it winds up very much colder than normal in here later next week into the following week. So it's quite a difference from its weekly forecast. Here's the precipitation across the nation, and here's the snow. This does not include the snow that is going through the Midwest right now. This is just new snow from later tomorrow on. So got some snow up in New England, and you see the storm path there. It wouldn't surprise me if this sinks even a little bit further south. Eastern Pacific Oscillation is strongly negative. Excuse me. That argues for more cold weather, right? However, the North Atlantic Oscillation argues for warmer weather, right? Because it's not negative. And at this time of the year, it's a very important forecast tool. Or is it negative? Here you are with a GEFS, which may have the better idea as to where this thing is going. See, the European is much more positive in here. GEFS is barely to neutral, and that would be a colder solution. Here's the Arctic sea ice forecast. Now, what did I do here? That is a good question. You know, I wanted to show you, hold on a second, folks. That's the Arctic sea ice forecast, which is off the charts, record-breaking, off the charts sea ice forecast. Now, everybody knows where I stand on the issue of what is causing the warmer planet right now. But I'm going to tell folks on my side of the debate, you better be careful with this Arctic sea ice stuff, because what I'm seeing in the CFSV2 forecast, I have never seen before. First of all, it is true that we're up here someplace which is above where we've been. What's happening is we haven't been getting as much ice during the winter, but we don't melt as much during the summer as this is a 2012 record down here. However, this idea that, we're up higher than we've been now, it's relative to what's going on. So this is what bothers me. I watched this CFSV2 like a hawk. It has never forecasted something like this. As a matter of fact, last year it forecasted this, and yet last year plainly didn't wind up near normal in the middle of the melt season, right? So it is forecasting something I've never seen it for. Not even in 2012 did it forecast that. And I have no idea if they tweaked the model, what's going on with it. I have no idea. I'm just pointing it out that it's forecasting a drastic event. And if that happens, it will be weaponized, believe me, by people trying to make a mountain out of whatever they want to make it with this warming. And maybe, that would be startling to me if that happened. But then again, it's been forecasted to happen a half dozen times. We're supposed to get rid of the Arctic ice cap. So 6 of this and half of that, half dozen. 6 of this and half of that. 6. I forget how that goes. Okay, so far for March, we're the 4th warmest March on record. Of course, we're only halfway through. We're halfway there. Living on a prayer. There's Tokyo, where it snowed this morning. It's been above normal. Got to watch what goes on in China. With cold, the reports of that flu, and they've been hit real hard over there. Supposedly they're diminishing, the cases are diminishing, and I'm trying to figure out, well, is it because they're getting a jump on warmer weather or whatever? I can't believe that there's not some kind of a link between the weather and that, but I'm not going to get into that. I'm just making you aware that we are watching what's going on there. And of course, it's been very much above normal here, but that's still cold. It's still below freezing up there, all right? Because the normals are so low, but they're coming up. Now, if you saw that in the middle of summer, then there'd be a reason to be melting the ice as much as what's going on. But you see, actually, up at the Arctic, it's actually been a little bit colder than normal. How about that, right? Colder than average. All right, it's normal to be cold in the Arctic. All right, you've been a good audience. Those of you who are still there, pat yourself on the back. and enjoy the weather. It's the only weather you got.